Now that we are familiar with what rational expressions look like, we're going to practice evaluating rational expressions at a given value. This process will be similar to what we did in the last task. However, some answers may be a fraction instead of a whole number. And this is just totally fine. Let's check out some example problems below. Example 1. Evaluate the expression when b equals 12. So we see we have a rational expression, b minus 1 divided by 3b minus 3. So we're going to evaluate just like before. Everywhere we see a b, we're going to plug in a 12. So we have a b, so I put 12 minus 1 over 3, and then I'm going to use my parentheses, plug in 12, and then minus 3. Notice I didn't put the parentheses around the 12 on top just because there's no number in front of it. There's no coefficient, so in that case, it's not necessary. Now, the only difference here between evaluating polynomial expressions is here you have to do the numerator first and then the denominator second, or vice versa. It doesn't matter the order as long as you do them separately. So instead of working down, generally it's easier to work across with these. So I'm going to start with the top. 12 minus 1 is 11. So that's my numerator simplified. And then on the bottom, I have to do PEMDAS again, order of operations. So multiply first, 3 times 12 is 36. And then do the subtraction. 36 minus 3 is 33. And that's a totally fine answer. If you are good at simplifying, you might notice that both of these are divisible by 11. And if you divide 11 by 11, you get 1. And 33 by 11, you get 3. And so then 1/3 is also a great answer. Also, if you type this into your calculator, 11 over 33, you would get 0.3333 forever, which can also be written 0.3 with a line over it. All totally fine answers. So if you want to stop at 11 over 33, that's fine. Now, a key difference with rational expressions from polynomial expressions in the last task is that if you want to use your calculator, then you want to use your calculator on the top to get the 11, then use the calculator on your bottom to get 33, eventually over here, and then divide to get the final answer. If you tried to type it all into your calculator at once, then you would need to put parentheses around the top divided by parentheses around the bottom. And so you might end up with a lot of parentheses and it can get confusing, just like all my scribbling is getting confusing here. So I recommend doing the top separate, doing the bottom separate, and then simplifying if necessary. So let's get another example. We want to evaluate this expression when x is -7. So again, I'm going to use my trusty parentheses, plug in the x value, -7, and then again, plug in -7 in the denominator. Now here, since I don't have space, I can't work. I would like to work horizontally, but I don't have space. So I'm going to work vertically, but I'm still going to focus on doing the top first, and then I'll do the bottom. So on the top, I start with exponents first. -7 squared is +49. Again, make sure on your calculator, if you're typing that in, that the negative is inside the parentheses and the squared is outside the parentheses. Then after exponents comes multiplication. I see multiplication right there. 9 times -7 is -63. And then -6. And the bottom. I know I haven't finished simplifying the top, but I'm going to jump to the bottom for the sake of keeping it equal. So on the bottom, I have -7. This came up before in the last task. A double negative turns it into +7 plus 31. And so now I'm going to jump back to the top, and working from left to right, I have 49 minus 63. That's going to give me -14, then -6. The bottom, 7 plus 31 is 38. And now I've simplified enough that I can fit this over to the right. -14 minus 7 is -20. And the bottom is already simplified. So all that work, I get -20 over 38. Again, if you're clever or just spend too much time doing math like me, you would notice that these are both divisible by 2. And then you could simplify to -10 over 19. Or if you entered that onto your calculator, you would get some kind of decimal. Let's see. I have a calculator handy. You could also get -0.5263 ... So all perfectly fine answers. So you might as well just leave it as a fraction if you want. Okay, one more example. Evaluate the expression when a is -4. Again, a different variable. Doesn't matter. So negative, parentheses, what goes in the parentheses? The 4 over something squared plus something minus 17. What is that something? It is our 4 again. So now I look at the top. -4. Since it's just +4, the negative on the outside just makes it a negative. So I have -4 plus 16. And that's going to be 12. All right, so I saw that I knew what the top was going to be, so I just jumped to simplifying the top before the bottom. So order isn't super important on these as long as you keep track of what you've done and what you haven't done. So I have not done anything with the bottom. So PEMDAS, do exponent first, 4 squared, 16. The 4 is just a 4, and then minus the 17. So working left to right, I add 16 plus 4 and get 20. And then subtract 20 minus 17 is 3. And now it actually works out very nicely. If you divide 12 by 3, you get 4. And so that's definitely the best answer for this problem. And so that is evaluating rational expressions at a given value.